Good morning, Geometry iPad students. This is Mr. Lane from OHS. We're going to be discussing section 3.5, which is line or slopes of lines. So you want to make sure and you get the title written down in your notes. You can read through the objective and the why, and then go ahead and answer number 5 down in your notes if you want full credit for your notes today. Hope you're having a wonderful day as we get to learning slopes of lines. A few things to go over real quick. Hopefully you remember some of this in your Algebra 1 class, but if it rises from left to right, it's going to have a positive slope. If it falls from left to right, it's going to have a negative slope. Any horizontal line is going to have a zero slope, and any vertical line, remember you can't walk up a wall, is going to have a undefined slope. We just can't do it. Alright, a few things about a little review. Remember, a lot of times when we have points, we count the rise, which is marked here in light blue. So the rise, we just count up to where the level of that next point is. So we count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to count the rise. And then the run, I've got it marked in green here, is how far we need to go over to meet that next point. So we want to go 1, 2 over. So we put our rise, or we count our rise first, and then we put that over our run. So in this example it would be 10 over 2, or just 5 for what we call the slope. Alright, now you definitely need to make a note of the slope formula. The slope formula is our y2 minus our y1 over our x2 minus our x1. So y is our rise over our run, which is our x's. Change in rise over change in run. Alright, let's move on. Now we got some quick examples here of some different slopes. If you notice, I already know going into it that 1 and 2 look to have a positive slope and 3 looks to have a negative slope. So all I'm going to do is do a little counting for these. So I want to go up 1, 2, 3 over 1, 2, 3. So my rise was 3 and my run was 3, which is going to give me a slope of a positive 1. Alright, on this one here, let's go a little bit different on it. Let's go ahead and write the points out and use the slope formula for it, just to get some practice using that. So this coordinate here is negative 3, 2. Write that down up here. And then this one's coordinate is negative 1, 3. And if you're just starting out doing this, you might go ahead and label through here what you want to be your x1, x2, so on and so forth. I'm just going to go straight across, calling this first point my point 1. So it's going to be my x1, that's going to be my y1, this will be my x2, and this will be my y2. That way, if you have that slope formula handy, all you have to do is fill it in as you go. So I'm going to write it down here, y2 minus y1 over x2 minus x1. Now I look across and I find my y2, which is 3. Minus is part of the formula, so I write it in there each time. And then my y1, my y1 is 2. I'm going to put that over. Now I look across for my x sub 2, which is negative 1, and I again draw that minus in there. And then I find my x sub 1, which is negative 3, so I'm just going to put it in parentheses. So on top I have 3 minus 2, which is 1, and then I have a negative 1 plus 3, which would be 2. So my slope for this one would just be 1/2. On this last one, we're going to go back to counting. So we always count our rise first. So I'm going to count that distance right there until I get even with the point. So that's 1, 2, 3, 4. So 4 is our rise. And then my run would just be that 1. So 4 over 1 would just equal 4. Regular geometry class will be doing 2, 4, 10, and 12 at this time. iPad initiative class, your homework's at the end of the lesson. Alright, next little example. It looks like Justin is driving home from his college dormitory at 4 o'clock p.m. He is 260 miles from home. At 7 o'clock, he is 455 miles from home. Must be driving away from his, unless he's calling the college dormitory his home, apparently. Alright, graph the line that represents Justin's distance from home at the given time. Find and interpret the slope of the line. Alright, so here's our graph, and it looks like it's got a couple of points already marked for us, so that's going to make it kind of easy. So let's go ahead and find the slope using the slope formula. So I'm going to label up here, we're going to call that x1 and this y1. By the way, we could call either point x1 or y1. As long as we follow the formula, it's still going to work. Alright, so I'm going to start with my y sub 2, and as you can see, I've got that marked as 260, minus my y sub 1, which is 450, over my x sub 2, which is 4, minus my x sub 1, which is 7. So I need to do a little subtraction here. Looks like on bottom is going to be easy one. It's going to be a -3. And on top, let's see, I'll have 450 minus 260. That should be easy enough to do. So I'm going to borrow real quick. And that's going to be 190. Alright, so now all I need to do is do a little dividing out here real quick. So let's see, I don't think I have the calculator on here. There it is. Alright, so we've got 190 divided by 3 looks to be 63 1/3. So we're going to write that down here real quick. So 63 1/3. So what's that represent if we're going that straight line all the way through? That means that he's going to average 63 1/3 miles per hour. So that's how we found his speed. Alright, next couple of things here are parallel lines theorem. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slopes. So if they have the same slopes, then they're going to be parallel. Perpendicular lines. Two non-vertical lines are perpendicular if and only if we multiply their slopes and it equals -1. So if they're negative reciprocals of each other. Horizontal and vertical lines are perpendicular to each other. So any horizontal and vertical line are perpendicular to each other. Alright, graph each pair of lines. Use their slopes to determine whether they are parallel, perpendicular, or neither. Well, I think we could actually get by this one with maybe not even graphing them, because we have the slope formula. So it looks like I have line UV here, which is the first 2 points. So I think I could label them real quick and just use a slope formula to find their slope, and then I could just compare it to the slope of XY. So let's see. My y sub 2 would be a -1, minus a 2 over a negative 1 minus a 0. So that's a negative 3 over a negative 1, which would just equal a 3. Now we need to do the same thing over here on this side. We've got our x1, y1, x2, y2. So we're going to have a 3 minus a 1 over a negative 3 minus a 3. So it looks like that will be a 2 over a negative 6, which would be negative 1/3. Well, they're not the same, so we know it's not parallel. But what happens if I multiply 3 times a negative 1/3? Well, notice the 3's are going to cancel out, and that's just going to leave me with that negative 1 left. So if I multiply them, I get negative 1. That tells me that these lines are perpendicular. Alright. If they came out to be the same thing, they would have been parallel. And if they weren't the same and they didn't multiply to negative 1, they would have been neither. So you're more than welcome to try those next two examples to see how it turns out. Alright, regular geometry class would be doing 8, 16, and 17 from page 118 at this time. And that looks like it's going to wrap up our lesson for today. So Mr. Lane signing off from OHS High School. Have a wonderful day.